So to be able to evaluate all possible splits, you have to first prepare a pivot table for each predictor. For each predictor you need to have the target ownership or non-ownership. So make sure that your cell pointer is inside the data set, and then click pivot table, and let's put the first pivot table right here. All right, so we have income, right, and then ownership, non-owner and owner. So you can bring ownership in here, and that will give you a count. Okay. Then we need another pivot table for lot size. That's how we will be able to consider all possible splits, right? Okay, so now we do pivot table a second time. So this time we will put this pivot table right there. Okay, now we use lot size, ownership.
It doesn't matter if we use lot size or ownership for that part, for values.
For values, it doesn't matter which variable you use, as long as you make sure that it is count, not sum. It should not be sum.
Sometimes do you need to switch it though, because right now it says sum for me.
Yeah, that's because, see, when you use numerical variable as the summarization variable, the default is sum. It will always set to sum. Then you have to go and change it from sum to count. But if you use non-numeric variable, like here ownership, that's the reason why I used ownership. When you use a non-numeric variable as a summarization variable, the default is count. So it automatically gets set to count, then you don't have to go back in and change it. Okay, so that is the second one. All right. So now we have the two pivot tables to do the computation. So right now, right at the top, at the root node, we have the entire data set, right, all 24 observations. And in that 24 observations, how many are owners? Well, I have non-owner first, and then owner. So how many are non-owner? So non-owner is G32, right, divided by I32, and okay, so I will put absolute reference in that fashion. So when I copy that over, I get the proportion of owners, right? Then at this point, for the root node, right? For the root node, what is the value of Gini index? So Gini index, remember, is this 1 minus the sum of squared value of each probability. So this will be 1 minus. Okay, let's do this. Start a parenthesis. 1 minus that squared plus that squared. So that's our Gini index. Remember, Gini index is between 0 and 0.5. 0 being completely pure, 0.5 being completely impure. So of course, at this point, the node with a 50-50 ownership and non-ownership is completely impure at this point. Okay. Now entropy is, okay, let's look at the formula for entropy. minus, okay, and then you have to multiply each p with its log to the base 2, right? So you have minus, okay, so start the parenthesis, each p, right, times log of that. Now when you use the Excel function log, okay, there are actually three versions of log in Excel. So we have ln, where the base is by default e, to the base e, and then you have log10 function. That function gives you to the base 10, and then you have log function where you can specify the base, and that base is 2. All right, plus you need to do the second one, p sub 2 times log of p sub 2 to the base 2. Finish that, and that's equal to 1. Okay. So, see, the entropy range is from 0, which is most pure, to log of m being the number of possibilities, right? Number of possible values for the target, which is 2. So log of 2 to the base 2 is 1. Okay. So between 0 and 1, 1 being the most impure, and we got that here, most impure.